So good afternoon once again. We are back with another video. We are still under trigonometric substitution and we will be solving another example for this video. So in this video we will be answering this example, a definite integral. We will be answering the definite integral still under trigonometric substitution. So we have evaluate integral of dx all over x squared, square root of 4 minus x squared from 0 to square root of 2. So in this example, we have here this equation is equivalent to 0 to square root of 2 dx over x squared, square root of 2 squared minus x squared. Now, as you can see, this is in the form of the first one, which is the a squared minus x squared. So, meaning to say, we will be replacing the value of x by a sine theta. Now, in this case, our a is equivalent to 2. So, as you can see from here, so meaning to say, our x is equivalent to 2 sine theta, and then our derivative of x, or our dx, will be equivalent to 2 cosine theta d theta. Now, as we know, as you can see, this is now different from the other examples, from the other videos that we have, because this is already a definite integral. So, meaning to say, the limits here will also be changed in terms of theta. So meaning to say, we will be changing the limits here. So as we know, this is our upper limit and this is our lower limit. So for example, when we change our limit, we need to substitute our x by the upper limit and the lower limit. So that being said, for upper limit, or UL, we need to change let x is equivalent to square root of 2. So if we change our x to square root of 2 from this substitution, we have square root of 2 is equivalent to 2 sine theta. Now to get the value of theta, since to get the value of theta, we have to divide both sides by 2. So we have square root of 2 over 2 sine is equal to sine theta. Now we just have to get the value of theta. So we have theta is equivalent to arc sine of square root of 2 over 2, which is equivalent to pi over 4. Meaning to say, pi over 4 will be our upper limits. We will be changing square root of 2 to pi over 4. Now, changing our lower limits, we have for lower limits, or LL, we have to let our x as equal to the lower limits value, which is 0. Now, 0 is equivalent to 2 sine theta, and if you calculate that one, theta is still equivalent to 0. So meaning to say, our lower limit is still 0. So now we will be changing this 2 from 0 to pi over 4, and then substituting the values that we have here. Dx is equivalent to 2 cosine theta d theta divided by, or all over, x squared, which is 2 sine theta squared, and then the square root of 4 minus our x, which is 2 sine theta. Then we have the squared here. So that's it. And then, since 2 here is constant, we can put that outside. So we have 2 here. Then the integral of 0 to pi over 4. And then the cosine theta d theta. We will be simplifying what's inside the radical sign here first before we move on to simplifying the general integrand. So from this one, we have, as you can see, that is 4 sine squared theta. And then the inside of the radical sign, that is 4 minus 4 sine squared theta, right? Then afterwards, we can factor this 4 here. So we have 2, and then 4 here is constant, so we can put that outside. That gives us 2 over 4. And then that's from 0 to pi over 4. And then the cosine theta d theta all over the sine squared, since we already put the 4 outside. So we have sine squared theta. And then factoring the common between the two terms, we have 4. And then 1 minus sine squared theta. So as we know, 1 minus sine squared theta, that is also equivalent to cosine squared theta. So meaning to say, we have 1/2 here, 0 to pi over 4, and then the cosine theta d theta. And then we have the sine squared theta, and then this will be changed again to cosine squared theta. And then afterwards, we'll just move this. And afterwards, we will be finding the square root of this. So we have 1/2 from 0 to pi over 4. Then we have the cosine theta d theta. And then we still have the sine squared theta. And then the square root of 4 is 2. So we have 2 here. The square root of cosine squared, that will be cancelled. So we have cosine theta. Now, as we know, cosine theta from the numerator and from the denominator can be cancelled. So we have d theta left from our numerator, and then we have 2 sine squared theta from the denominator. And 2 or 1/2 here is constant, so we can put that outside, and that will give us 1/4 from 0 to pi over 4. And then we have the d theta left, and then we have the sine squared theta from here. Then afterwards, we know from basic identities, trigonometric identities, 1 over sine squared theta is also equivalent to cos secant squared theta. So we have from 0 to pi over 4 still, that is equivalent to cos secant squared theta d theta. And there is already an equivalent integral for cosecant squared theta, which is equivalent to 1/4. And then the integral of cosecant squared theta, that is equivalent to cotangent theta from 0 to pi over 4. And then afterwards, since we already got the integral of our integrand, we can already substitute our limits to our variable. In this case, our variable is theta, so we have to substitute our limits. For this case, since this is a definite integral, there's no need to return the variable back to its original variable because we are finding the constant value. So for this one, that's okay to already substitute our limits in our variable. So we have cotangent pi over 4 minus cotangent 0. So we to calculate that one, that is equivalent to negative 1 over 4. So meaning to say our final answer is negative 1/4. So that's it for this example. So since this is a definite integral, meaning to say your answer should also be a constant number or a constant value. So pasting again our much um, much visible solution, we have here this one. So I hope you learned from this discussion, and I hope to see you in the next video. Thank you so much for listening, or thank you so much for watching this video. That's it for this topic for trigonometric substitution. I'll see you in the next integral calculus topic. Bye.